Harold from Masonry Fixing Services. We just want to offer this video to educate the installers as to some of the problems that you may encounter on construction sites. As construction methods develop over the years, construction sites are becoming much more demanding environments, requiring that everybody involved in the build understands every aspect of the build. And fixings are no exception to that. Fixings are often considered in accordance with their monetary value, when in fact their safety can't be underestimated or understated. Very often fixings are used to hold large, heavy elements of the building together, and the failing of a fixing can result in quite catastrophic results. What we're trying to do in this presentation is to outline a lot of the sort of typical or common fixing errors that we come across with regard to installation, so that you guys who are doing the installations can actually fully understand what to do when you're faced with some of the situations that we're going to outline. Ordinarily, when we come to the site project and we give this presentation, we give all of the attendees a copy of a small 15-page leaflet which contains all of the issues that we're going to discuss. It's quite handy because you then can make notes in the book, you can keep the book, and you can refer to it afterwards if there's something that you can't recall from memory. We also offer the same points on an A1 page, which is given to the site manager so that he can put it up around the site where he thinks it might be important for the installers to be able to come to and reference. If you're watching this on video link, then you may not have received copies of these documents, and I would suggest that perhaps you should phone the office and ask for copies of them, because they're good to have on site. Fixing hint number 1. Anchor code of practice equals best practice. So what is an anchor? Some people think an anchor is on a ship. An anchor is a fixing. And a fixing is to make stable, secure or attach. Construction fixings with anchors are structural connections to concrete, and those connections can be made with mechanical anchors or with chemical anchors, similar to what you see in the box here. There's a vast range of chemical anchors, from chemical injection systems to chemical capsule systems, right across to mechanical expansion anchor systems. So there are lots of different systems on the market for attaching steel to concrete. Examples of fixtures would be balconies, staircases, structural base plates, handrails, crash barriers, mechanical and electrical installations overhead, etc. There are lots of different applications. For the purpose of this presentation, we're talking about safety critical situations. And a safety critical situation is defined in the Code of Practice as a situation where failure would result in either human injury or death. Fixing hint number 2. What is the Code of Practice? The Code of Practice is a user-friendly guide to best practice for the design and installation of anchors in concrete. If you're involved in specifying, buying, supplying or installing anchors, you need to know about it. It defines the roles and responsibilities for everyone involved. And it's all about safety critical situations, where, as I said earlier, safety critical situations would result in injury or death in the event of a failure. So you really need to get clued in, because this thing could go horribly wrong. The Code of Practice itself looks like that. It was published in 2010 by the Health and Safety Authority, and it outlines all the roles and responsibilities for everybody involved. As I said, from the manufacturer to the supplier to the specifier to the buyer to the installer. And so you need to perhaps find the relevant section of the document that relates to you and try and understand its content. What we at Masonry Fixing Services have done is we've taken the relevant sections for the different duty holders and we've put it into a little summary or a little pamphlet. This particular pamphlet is about the Code of Practice for the design and installation of anchors in concrete, and it's for contractors and installers. So it's for you guys, the installers. And maybe, if you haven't seen this already, you should request a copy of it from your representative at Masonry Fixing Services. So fixing hint number 3, anchor approval and selection. In all safety critical situations, the anchor must be fit for use. It should have an ETA, a European Technical Assessment, and it should have a CE mark on the product. The ETA or the CE mark must be relevant for the particular application where you're going to use the product. You should obtain technical data from the supplier, and you should have your design approved by a competent person. If you have any doubt, please contact your supervisor. With regard to ETAs, what I would say is that a European Technical Assessment is a document that looks like that. It's around about an 18 or a 20-page document, which is basically the birth cert for the product. So this document will tell you everything about the product's intended embedment depths, anchor spacings, edge distances, tightening torques, drill hole diameters. Everything you need to know about the product is in that document. That document can only be attained by the manufacturer when there is what we call an EAD, a European Assessment Document. The EAD is basically a document that outlines the use of the product. So there would be an EAD. This particular EAD is for mechanical anchors for use in concrete. There'd be EADs for insulation products, for glass products, for sealant products, for fire stopping products. There's lots of different EADs. When there's an EAD, the manufacturer can then have the product tested in accordance with the EAD. This particular document is a 58-page document. It's quite a large document. And it's only when it's tested in accordance with the EAD can it attain an ETA. You may find that with some products, chemical injection resins, for example, these products may have 2 or 3 different ETAs, because the product, the ETA, the European Assessment Document, is about the application of the product and not necessarily the product itself. So for example, if this product is designed for use with threaded bars for fixing into concrete, it will have an ETA for bonded anchors into concrete. If it's also suitable for use for, say, post-installed reinforcement bars into concrete, it will have an EAD or an ETA for use with post-installed reinforcement. And that will also have been assessed in accordance with a different EAD. It might also be suitable for use in masonry with threaded bars. And there will be an EAD for resin anchors for use in masonry, and if the product is tested in accordance with that EAD, it will have a third ETA. So that means there will be 3 different CE marks for this particular product, or there could be 3 different CE marks for this particular product. So be mindful that the CE mark is to do with where you're using the product. You may have a product that has been tried and tested in concrete, and there's a CE mark on the package and a CE mark on the box, and then you're going and you're using that product in a block. It's not relevant. The CE marking on the packaging is not relevant for that application for using that product into block work. So please be very careful that you have the correct CE mark on the product. Fixing hint number 4. Before you install anchors. Before you install any anchor, you should check that the anchor supplied meets the specification. So if for some reason purchasing have maybe changed the product or changed supplier, that's fine so long as the product being changed meets the specification, and maybe change management should be carried out in that case. Check that the CE mark and the ETA on the box are relevant. So on all the packaging you'll see the CE marking, you'll see the CE mark number, and you can trace that and see what the particular application is. So if the application is for use in concrete from the ETA or from the CE mark, and you're going to try and use it in block work, then stop. You should not do that. You have to make sure that you're using a product with an ETA that's relevant to the particular application that you have. Make sure that you have the correct tools to hand. So quite often when you're installing these anchors, there's different setting tools, different drill bits that are required for setting different types of anchors. Make sure you have the correct ones, because if you don't have them and you go to site and you start to make the installation, and you're suddenly halfway through the install and you realise you're missing a particular critical tool, the tendency is to try and find some other clever way of getting over the problem and not using the tool or making a tool out of a screwdriver or a bit of rebar. Don't do that, because that is going to lead to a problem afterwards. Make sure you have all the correct tools before you start. Make sure you know the correct setting depth. The anchor setting depth is imperative to the resistance capacity of the anchor in the concrete. If you change the embedment depth, either reduce it or increase it, then you're going to increase or reduce the anchor capacity. So again, don't do stuff like that. Ensure that you have received any appropriate training required for the installation of the anchor. And if you've any doubt, contact your supervisor. Fixing hint 5, embedment depth. Embedment depth is critical for anchor performance. Anchor performance depends on it, totally. It means how deep the anchor is set into concrete. The embedment depth depends on the drill hole depth. Check the design and check the installation instructions for embedment depth. If you can't achieve the specified embedment depth, then stop and contact your supervisor. It's not okay to carry on with maybe 50% reduction in embedment depth because your drill bit was too short or because you encountered reinforcement when drilling the hole. If you do that, you're going to dramatically reduce the resistance capacity of the connection. So please make sure you achieve the specified embedment depth. Fixing hint number 6, non-cracked and cracked concrete. Concrete under tension has very small cracks. I have set up a piece of insulation on the table here to demonstrate how concrete might crack. This, if you can imagine, is to represent a concrete slab supported on two walls. In its static condition, without any loading, the concrete is completely flat. When it's loaded, it deflects, as you can see. Okay? If I press heavily on that, I'll actually break the piece of insulation. If it was concrete, it would be the same. Now, when I press down on it, the top surface is trying to shorten and the bottom surface is trying to lengthen. So the top surface is in compression and the bottom surface is in tension. Concrete is very, very good in compression. So if you took a concrete cube and you press down on it, it can resist very high forces. However, if you take a piece of concrete like a concrete cylinder and you try to pull it apart, it will snap quite easily in the centre because it doesn't have very good tension capacities. This is why we put steel reinforcement into concrete. The steel gives the concrete the tensile capacities that it needs. In a situation like we're showing here, if I press down on that, obviously the underside is in tension and that's where the steel reinforcement would be located. There are anchors specifically designed for use in cracked concrete which allow for follow-up expansion. So if, in other words, we install anchors into, in this example, into the underside or the soffit of the slab, and then afterwards the building is finished and it's loaded and the loads come on the concrete elements, and small cracks, small hairline cracks, you won't even see them, they're only about 0.3 of a millimetre. When those cracks occur, if the anchor is located in that crack, it may try to drop out. Some of the specially designed anchors can exhibit what they call follow-up expansion to be able to cope with it being located in a crack. Anchors with an ETA or a CE mark based on an ETA option 1 to 6 cover applications in non-cracked and cracked concrete. Anchors with option 7 to 12 ETA or CE marking only cover non-cracked concrete. So if you're not certain which anchor you have or what concrete condition you have, if in doubt, assume the concrete to be cracked. And if you're still unsure, then contact your supervisor and get clarity on the situation. Fixing hint number 7, corrosion protection. Different materials have different corrosion protection properties. Always make sure you use the correct one. Anchors come in various different finishes. You can get an anchor in zinc plated, which are designed for use in dry internal conditions. You can get anchors in hot dip galvanized for sometimes damp conditions. And you can get A4 stainless steel for exposed wet conditions. There's also a special C grade stainless, which is 1.4529 grade stainless, for use in swimming pools and road tunnels where you have high corrosive conditions or elevated temperatures. Please make sure you don't ever mix the different metals because, for example, if you put a stainless steel anchor plate with a zinc plated anchor, then the two metals will have a bimetallic reaction and you'll have corrosion of the less noble metal, which in that case would be the anchor. Alternatively, if you have a stainless steel anchor and a carbon steel base plate, again you'll have a bimetallic, or you potentially have a bimetallic reaction in a damp environment, and the base plate will corrode. So never ever mix your metals. Fixing hint number 8, drilling the drill hole. Use the correct drilling system. Systems available on the market are typically what we call SDS Plus, which is a quick release drill bit which just simply inserts into small hammer drills. That will drill the hole using rotary and hammer action, breaking out the concrete parts and extracting them using the fluting on the drill bit. That's SDS Plus, and the big brother of SDS Plus is SDS Max for the larger size drill bits. They're the most common drill type systems that you might be using. Drill dust has recently been identified as being carcinogenic, and so it's not very healthy to be inhaling drill dust that's airborne around you. So there are SDS Plus and SDS Max versions of dustless drilling, where you have no fluting on the drill bit because there are holes in the top of the drill bit. You attach a vacuum, an M-class vacuum to the drill bit, and as you drill the hole, the drill dust is extracted through the centre of the drill bit and into the vacuum cleaner. So it's a much more environmentally friendly way of drilling, and from a health and safety point of view, the installer is not inhaling any drill dust. The other way to drill then is what's called diamond drilling, where we have a pipe, a hollow pipe with some diamond segments welded onto the tip of the pipe. Basically, that goes into a drilling machine that operates just on rotary action, not on hammer action. There'll be a water feed going through that drill bit, which will cool the tip of the drill bit. So that basically grinds its way through reinforcement if you have to drill through reinforcement. We'll talk a little bit more about reinforcement in one of the next hints. Make sure that you use the right drilling machine for the right on the right setting. So don't try and drill very large holes with small machines. Make sure you get the correct machine. Use a drill bit that has a PGM mark. That is absolutely imperative. There's a marking on the side of the drilling machine. You'll see it on the illustration behind me, where it's PGM, which is Proof Gemeinschaft Bohrer. It's a German organisation that regulates the tolerances on drill bits. If anchors are installed with PGM marked drill bits, then the anchors will perform as they're intended to perform. If anchors are installed in holes which have been drilled with non-regulated drill bits, then the tolerances on the drill bits could be wrong, the drill hole diameters will be inaccurate, and the fixing won't behave as it's supposed to behave. So make sure that the drilling system you have is a PGM mark. Check that the drill bit is the right diameter and the right length, so that when you get to site you don't have a problem with achieving the embedment depth of the anchor. Make sure you have drilled straight and perpendicular to the surface. So when you're drilling into the concrete, make sure you're perpendicular to the surface. Don't drill in at an angle, because the fixing will then be at an angle. And as you tighten the fixing, you're going to start to damage the fixing. Sometimes people might have a base plate with a steel column coming up off the base plate, and they arrive with a very large drilling machine but physically can't get in close to the column, so they go in at an angle. Don't do that, because the fixings will be rejected if you do that. And use your depth stop to ensure that you do achieve the correct drilling depth. Fixing hint number 9, cleaning the drill hole. Check the installation instructions for guidance. Have a blowout tool and a brush set at hand. Blowout tool, proprietary product for blowing dust out of drill holes, and a brush for cleaning out the hole. Pay special attention with resin anchors, because obviously the resin is going to adhere to the wall of the drill hole, and if there's drill dust between the resin and the wall of the drill hole, it acts as a barrier and your fixing won't behave or perform as it's supposed to. Remember to blow, or to blow brush blow as instructed. I would say at this point that there are some chemical anchors now on the market where you'll be told you don't need to clean the drill hole. Be very, very careful. If, for example, you use the dustless drilling system that I showed you in the previous hint, then that drilling process cleans the drill hole, so you don't have to actively clean the drill hole. The drill hole is cleaned out passively by the drilling system. Some of the injection systems as well, some of the glass capsule systems are rotated, the anchor stud is rotated into the capsule on rotary and hammer action. So that actual rotary and hammer action with the glass and the quartz that's inside in the capsule will tear all of the remaining drill dust off the wall of the hole and incorporate it into the matrix of the resin mix. That installation process is cleaning the hole. It's passively cleaning the hole. So be mindful, yes, there are resin systems on the market that you don't have to actively clean the hole for, but the hole is being cleaned. There is no resin system that will work when there's drill dust between the resin and the wall of the drill hole. Fixing hint number 10, if you hit reinforcement. And what we mean by that is when you're drilling the hole, if as you're drilling into the concrete you encounter reinforcement, you won't probably be able to drill through the reinforcement, depending on the size of the drill bit and the size of the reinforcement. Reinforcement is in concrete for a reason, which I explained earlier on. It gives the concrete its tensile strength. If you hit reinforcement, some people think that when they hit reinforcement, the answer is to drill again and again and again and again, and they end up with a load of holes in close proximity that makes the concrete look like a bit of Swiss cheese. Don't do that. If you hit reinforcement, stop drilling. Contact your supervisor. Do not proceed, and only resume work once you've been given clear approval and instructions as to what to do. Sometimes when you see steel cages on concrete in formwork before the concrete is poured, you'll see that there's link bars tying the main bars together. It may well be that you're hitting link bars, and the link bars aren't that relevant to the tensile strength of the concrete, so the engineer might allow you to drill through the link bars, and you will do that using diamond drilling systems, which I talked about in the hint about drilling. So if you hit reinforcement, stop. Don't try to be clever, don't install the anchor at reduced embedment depth, and don't try drilling lots of holes. So fixing hint 11, site tolerances. Sometimes due to site tolerances, if perhaps you have to fix a beam onto concrete, either horizontally or vertically, it may end up that there's a gap between the bracket and the concrete, and it's not okay to leave that. It's also not okay just to put in some shims or some grout. It may be okay, but you need to check it, because if you leave it, a couple of things will happen. First of all, if you've got a standard anchor that's designed to fix, for example, 10 millimeters of fixture, and now you've increased that to 40 millimeters, then you've actually stolen some of the anchor depth from the embedment, so you've reduced the tensile capacity of the anchorage. If it's in shear, the shear is now, instead of being a pure shear, it's shear with a lever arm, and the anchor is going to go into bending, and that can quadruple the shear action on the anchor. If you ignore this, it could result in failure. So please don't leave it. Talk to your supervisor and get advice as to how you should proceed. Fixing hint 12. Never cut or weld anchors. This is quite simple. Don't alter any anchor. Don't shorten any anchors. Don't change any anchor components. If you have the wrong anchor, get the right anchor. You'll see on the picture beside me how some people think it's okay to either cut or weld or change or alter the anchor. Do not do that. Fixing hint 13. Make sure the concrete has reached design strength. The anchor and the concrete work together. In fact, there's three pieces. There's the anchor, there's the drill hole, and there's the concrete. All three pieces work together. Green concrete or fresh concrete will not offer the correct concrete capacity. Sometimes we get people trying to install anchors into concrete that's a day old or 2 days old. Do not do that. The concrete has to have reached its full strength. If when you're drilling you suspect something is not right with the concrete, then seek advice. Guys that are drilling all day every day will know if they drill concrete that's green or fresh, the drill dust, the feeling will be different. Another check is that the anchors, most of the anchors, all of the anchors when they're installed have to be torqued. And you probably will struggle to achieve torque, installation torque, if the concrete is fresh or green. We've had some experience with GGBS concrete, where GGBS has a very slow early cure time at low temperatures. You may experience that problem. Another thing to be mindful of is with hollow precast concrete slabs. If you're fixing overhead into hollow precasts, or even from topside on hollow precast slabs, don't drill into the solid sections where the tendons are. You cannot drill through, or you should not damage a tendon in pre-stressed concrete. You should drill into the hollow section of the concrete and use an appropriate anchor that's suitable for use in the hollow section. Fixing hint 14, installation of drop-in or wedge anchors. The technical term for these products are deformation controlled anchors. If you look in the EAD on the AOTA website, you'll see that they're listed as deformation controlled anchors. The reason being that the anchor basically is like a small tube, with some slots on the end of it, and inside in that tube there's a little wedge or a little pellet or a little cone, whatever you want to call it, a little metal cone. And what you simply do is when you drill your hole, you clean the dust out of the hole, you insert the anchor into the hole, and then you take a proprietary setting tool and you set the pellet. Now you'll see that in that condition there's a gap now between the face of the anchor and the face of the setting tool. The idea is that you hammer that setting tool, that you drive the pellet back, the pellet deforms the anchor. Here's one that's already deformed, until such time as the surface of the anchor touches the surface of the setting tool. Then you know the anchor has been set correctly. It's a deformation controlled anchor, so you're deforming it by a controlled amount. With this particular setting tool, there's a design on the surface which will leave little witness marks on the face of the anchor. Again, you'll see that in the graphic over my shoulder. That's a very simple check to make sure that the anchor has been installed correctly. I should point out, however, that there is a setting tool which has an SDS end on it for going into the drilling machine, which can also be used for setting the anchors using the hammer action of the drilling machine. However, it does not have this shape on the face, so the anchors could actually be set correctly using these tools, but you won't have a witness mark on the surface. The best way to check that is to just simply take the tool and install it into the anchor, and if the face of the tool touches the face of the anchor, you know it's been set correctly. Remember, most of these type of products are used overhead for cable containment, for anything that's services systems, M&E systems. So they are very much a safety critical situation, and if they fail, you're going to have a collapse down from the ceiling. Fixing hint number 15. Installing bolt anchors or sleeve anchors. Sleeve anchors look like that. Bolt anchors, probably the most popular type of product on the market, are those type of products there. Before you install any of these anchors, make sure you have all the correct setting tools. Check the manufacturer's installation instructions. Make sure that you've got the right product and you know how to install it and you have all the right tools. Drill and clean the hole properly. So again, after you've drilled the hole, brush it out, blow it out, whatever's required on the box, on the packaging, clean it properly. Ensure with the bolt anchors that the nut is up close to the top, about 3 threads from the top, because if you install it with the nut down the bottom, then you've already reduced the embedment depth of the anchor. They're designed to have the nut up near the top. There's a section on the top, there's a nipple on the top with a non-threaded section so that it's protected from hammer blows as you're driving it in, so you don't damage the threads. So bring the nut up to within 3 threads at the top, take your hammer and simply hammer that home into the drill hole. After you've set that anchor in, these anchors, if you go on the EAD, on the IOTA website, they're called torque controlled expansion anchors. They're not called torque controlled expansion anchors for fun. They're called torque controlled expansion anchors because after they've been installed, they need to be torqued. So you need to get yourself a torque wrench. This particular torque wrench here has a digital readout on it. So as you get to the correct torque, it gives a beep, a beeping to let you know that you've reached torque. The standard conventional torque wrenches have a neck on them that give a crack or a snap to know that you reach torque. But you have to set the anchors with the torque wrench. That will do a few things. Firstly, it means you've installed the anchor correctly. If the concrete is suspect, or it's green, or it's fresh, or it's GGBS, or whatever it happens to be, and the anchor isn't going to behave correctly in the concrete, you will identify that because you won't be able to achieve torque. So then you know you have a problem before it becomes a big problem. The other thing to know is that when you torque the anchor, you induce a pre-stressing, a tension pre-stressing into the bolt because you're trying to withdraw the bolt and you're generating a clamping force where you're clamping the bracketry back down to the concrete. The pre-stressing force that you generate in that anchor is quite high and should negate the need for any testing on site afterwards because you've already essentially tested it once it has achieved torque either by clicking or by beeping. So, very important, apply the correct torque with a calibrated torque wrench. Fixing hint 16, concrete screws. Undercut screw anchors. So the concrete screw is the latest product to the anchor family. It's around about 10 years, but it's the latest bit of technology. The concrete screw basically is like a self-tapper for concrete. So the important thing to know again is to check the manufacturer's instructions before you install the anchor. Drill the hole, clean the hole, and insert the anchor using either an impact driver or a torque wrench. Now, be very, very careful, because the ratings on an impact driver or an impact wrench, electric impact wrench, will be, I don't know, this one is in the area of about 140 Newton meters. There will be two settings on the box for the product, two torque settings. One will tell you what the torque setting for, or the rating for an impact driver is, and one will tell you what the rating for a torque wrench is. And you'll find that the rating on the impact driver might be about 140 Newton meters, whereas the setting torque, depending on the diameter of the anchor, might be around 50 or 60 Newton meters using a torque wrench. Don't mix those two values up. These are fantastic for driving the anchors in, because you basically just simply apply the socket to the end of the impact driver. See, there we go. Insert the anchor into the socket and drive it home into the drill hole, and it cuts its own threads into the drill hole. The beautiful thing about it is it's removable as well. So if you have any temporary works precast units which have props, temporary props holding them, you can install it with these products. And then you can remove them and there's no trip hazard afterwards. I should say that when you check the approval for the product, some products are approved for reuse, others are not. The ones that are approved for reuse will come with a little checking gauge. If the checking gauge cannot fit over the anchor, it's okay to reuse the anchor. Every time you use the anchor, you'll wear down the threads ever so slightly. When they get to a point where the wear indicator rides up over the threads, you must sling it away and take a new anchor. Some people ask, will I get 3 uses, 4 uses, 5 uses? It depends on the strength of the concrete you're going into. If you're going into 50 Newton concrete, you might get 2 uses. If you're going into 25 Newton concrete, you might get 6 uses. The real way to know is to check it with the wear indicator. So again, the anchors also are allowed to be slightly removed and retightened with the hand torque wrench if you've got handrails for adjustment. Fixing hint 17, installing undercut anchors. Before you install any undercut anchor, you have to check the installation instructions on the anchor. Use the correct drilling system. Drill and clean out the drill hole. You must use the manufacturer setting tools, and you must then apply the correct torque with a calibrated torque wrench. Undercut anchors are a very, very particular breed of anchor. They come in 2 different forms. You have one whereby you drill the hole with a standard drill bit, and then the drill bit rotates and creates an undercut, or like a larger section at the base of the drill hole, into which the anchor is then placed. And with a special setting tool, you drive the anchor sleeve down over the taper and it sets into the concrete. The other type is what we call self-undercutting, where you have an arrangement on the end of the anchor here. You'll see it happening behind me here on the screen, where the anchor is rotated, or the anchor body is rotated, and it has 2 tungsten carbide tips on it, and it actually forms an undercut in the concrete. It's called self-undercutting, as opposed to these ones where you undercut with drill bits. These anchor types, if they're specified and you're expected to use them, are very, very sophisticated. The installation process is not very straightforward. Make sure you get trained on the correct installation process. Make sure you get trained, because these will bite if you don't have the proper knowledge. Fixing hint number 18, installing bonded anchors. Before you install any bonded anchors, you should check the installation instructions. Make sure you have all the necessary tools, very, very important. Drill the hole to the correct drill depth. Clean the drill hole correctly, that's very, very important for chemical anchors. Use the correct setting technique for capsule systems or injection systems, and observe the curing time before loading. Just very quickly explain the difference between an injection system and a capsule system. The injection system is a 2-part resin coming in various different dispenser forms. This one here is what we call a shuttle cartridge. It's a side-by-side cartridge, and there's a static mixer, or a nozzle that goes on the top. There's a worm inside in that mixer, so as you extrude the 2 components in the special applicator gun with the 2 pistons, the product is mixed in the nozzle, and as you extrude, the mixed resin is then injected into the drill hole. The glass capsule system is a system whereby you have a glass capsule and you have resin inside, and you have another file inside again with the hardening agent or the catalyst inside in it. You drill the hole, clean out the hole. Some of the newer ones you don't have to clean out the hole, because as I explained earlier, the drill dust gets brought into the mix of the capsule. So you drop the capsule into the hole and then the setting tool or the threaded bar for the glass capsule system will have a chisel point on one end for mixing and smashing the two capsules and a drive mechanism on the other end so that it can be driven in on a drilling machine. So that threaded bar is driven in on rotary and hammer action. It smashes the two capsules, it rotates and mixes everything, including the drill dust, into the matrix of the resin mix. With the injection resin system, you simply have standard FISA anchor studs. Flat-ended, they don't need to have a chisel point for mixing, they don't need to have a drive end, because you just simply rotate them in by hand into the pre-mixed resin. Fixing hint number 19. Number 19 is responsibilities. All the responsibilities are well laid out in the Code of Practice. The specification and the design of the anchor is done by the designer or the project supervisor of the design process, or the PSDP. The technical information and the installation instructions on the product itself will come from the anchor manufacturer or the anchor supplier. And then the correct procurement and installation of the anchors is coming from the contractor and the installer, and the project supervisor at the construction stage will oversee that. Basically, we're all part of the solution, and if everybody plays their part correctly and everybody understands what their role is, fixings should not give trouble on construction sites. Thank you very much for watching. I hope you found that informative. There's a lot of content in it. If you have any questions on any of the content, please feel free to contact our engineering team or our technical sales team. All our contact details will follow on the next slide. Thank you.